So this video is a review of test number 2, probability and probability distributions from fall of 2019. So I'm just taking you through the solutions to each of the problems. Some of them are pretty straightforward, so I took the liberty of just jotting down the solutions beforehand. So number 1, it's asking what is the formula, just the formula, to determine the mean of a binomial distribution. So there I'm just being asked to make a statement of what the formula is. So mu equals NP and call it a day. Part B, or the unofficial part B, are there any restrictions to the value or on the value of a probability? The answer is that yes, there is a restriction or set of restrictions. Is just that probabilities have to be between 0 and 1, right, inclusive. So it can be equal to 0, it can be equal to 1, and anything in between, but it can't be beyond those values. For number 2, the 4 conditions that must be satisfied in order for a distribution to be considered binomial. You have a fixed number of trials, fixed probability, independent events, and 2 outcomes. All right, so pretty straightforward stuff, just statements of fact. The first one where you have to do any kind of real work is number 3, and that's the case where it's saying if it's a probability distribution, then you have to compute the mean and the standard deviation. All right, so in order to be a probability distribution, so to be a, poor quality a probability distribution, the sum of P of X has to be equal to 1. All right, it's really X sub I. The sum from, if I'm going to be technically correct about it, it's I equals, poor quality equal sign, 1 to n. All right, so that's the proper notation. The nth term, which in this case would be 9. So I'm looking at, again, it's just notation, but it's saying if I have the first value going to the 9th value, in this case because the first value is 1, use a highlighter, and the 9th value, the 9th value happens to be 9. It doesn't always play out that way, but that's the way it is in this case. If I were to take those the probabilities associated with those values and add them up, the result should be equal to 1. I don't know if that's necessarily the case. So that's where the calculator comes into play. So I'm going to type the information into my calculator. Pretty straightforward. Stat, edit. I put the X values into L1 and the Y values into L2. Now, it's a kind of a chicken or the egg sort of thing. I don't know that you necessarily want to compute the mean and standard deviation until you know it's a probability distribution, but one of the ways in which you can get the sum of that P of X column is to determine the mean and standard deviation. All right, so let me just show you that way because I think that's going to be the most user-friendly. Because bottom line is you gotta type these numbers into your calculator one way or the other. Why not do that for or with a purpose? All right, so I'm going to operate under the assumption that I typed the numbers in correctly. Quit out of here. Stat, calc, 1 var stats. My information is in L1 and L2. Again, slight differences between my calculator and yours, so you just got to make sure that you know how to operate it on yours. So it's similar enough that you should be able to navigate. Calculate. What we're looking for is that n value to be equal to 1. All right, so that bottom value there where it says n equals 1, that's exactly what I was looking for. All right, so yes, it is a probability distribution. All right, so it's definitely a probability distribution. Now I can state that mu is equal to, poor quality equal, still not much better on the equal sign, 3.44, if we're going to 3 significant, and that's our assumption, 3.441, and mine says SX equals domain, yours will say SX equals blank. All right, we want the sigma 2.461. All right. So that n value equal to 1, that is what the calculator. So when a calculator is determining what the n value is in a data set, it's determining the sum of all the frequency values. Okay, so it's adding up the frequency column. In this case, the frequency column is P of X. So it's indirectly adding up all of our P of X values for us. All right, so if that number is equal to 1, then we're in good shape. Also verify that the numbers themselves, those P of X values individually, follow the rules of being probability values. They themselves have to be between 0 and 1. If that's not, like if you had a negative value in there, or if you had something bigger than 1, it would not be a probability distribution because my column of P of X would not contain only probability values. All right, so moving on, we get to number 4. A coin is flipped 5 times. What's the probability that at least 3 of those flips turns up a head? All right, there's a couple of ways to handle that. What I like to do is list out all my possibilities. All right, so it's flipped 5 times. So the number of heads could be 0. Maybe you didn't get any heads. It could be, get my wrist guard up here a little, poor quality. Or, you know, that wrist guard is garbage. That's hilarious. Or 1, or 2, or 3. Gonna move things over a little bit. Or 4, or 5. All right, so the number of heads, when I flip a coin 5 times, I can get no heads. I can get only 1 head. That would mean I got 4 tails. I can get 2 heads, which means 3 tails. 3 heads, which is 2 tails. 4 heads, which is 1 tail. 5 heads, which would be no tails. All right, so what I'm going to do is decide. You know, like I can use Binompdf. If I'm using Binompdf, I would want to find Binompdf for each of these 3 values. So I would compute Binompdf for each one of those values and then add them all up. I could do that using a table approach. Or I could use Binompdf. Right? I'm going to do the Binompdf method first, and then after that I'm going to do Binompdf. You can decide which way you want to do it. I'm only looking for you to show the method one way or the other. All right, so if we're doing it with the table approach, let me zoom in a little bit, extreme close-up. Whoa! That's a little Easter egg for 1 bonus point. If somebody sends me a message with that Easter egg, I will, like I said, give you 1 bonus point. All right, first come, first serve, though. All right, so the table method, we're going to put 0, 1, 2, 3, 4, 5 is going to go into L1. So stat, edit. I'm just going to wipe out both my columns. 0, 1, 2, 3, 4, 5. All right. Then what I'm going to do is on L2, I'm going to hit enter. And then I'm going to select Binompdf. So you would have to hit enter onto the L2. I don't have to do that. So second vars, I'm going to find Binompdf. Yours is going to be option A also if it's a TI-84. If it's a TI-83, it's option 0. The N, which is the number of trials, 5. Probability of success. You flip a coin, you have a 1 in 2 chance of getting the side that you want. I'll put it in as 0.5 for convenience. And my number of successes would happen in L1. All right, so these are all my possible outcomes and their associated probabilities. All right, so we're in pretty good shape here. Now all I'm going to do is account for the ones that I want. I only want 3, 4, or 5. All right, so what I'm going to do, and I I recommend that you copy the values over to L3 so that if you make a mistake and you want to go back and edit, you still have the original set of values to work with. All right, so I'm going to go into L3, hit enter. That brings the blinking cursor to the bottom of the screen. I'm going to bring in L2. I want to get rid of the first three values, so I only want to keep the last three values. All right, so delete, delete, delete. All right, so the ones associated with 3, 4, and 5 should still be there. The 0.3125, the 0.1562, and the 0.0312. All right, so just to show adequate work, I'm going to indicate those values here. I'm going to say, I'm going to zoom in a little bit, probability of 3 plus probability of 4 plus probability of 5. All right. And again, those entries, we can go with the rounded values, just like we did in the notes. About 0.31, 0.16, and 0.03, because we're not actually using those values. So I'll put a little approximate symbol there. All right, what we're going to do is use the sum function in our calculators to actually have it add up the sum or add up the values in L3. So I'm going to quit out of here. Second, stat, math 5, tell the calculator L3, and then hit enter, and shockingly it ends up being a clean 0.5. All right. So it actually turns out that it's exactly the sum of those three rounded values, but it turns out it's the sum of those three unrounded values that's also going to be equal to 0.5. So, you know, sometimes you get lucky. All right, the next approach would be to use the Binompdf technique. All right, so Binompdf will give you the probability of, at most, a particular set of outcomes. So in this case, I'm looking for at least 3. So what I would do is find 1 minus the probability of at most 2, because that's everything else. It's the complement, which in notation form would be 1 minus Binompdf. So 1 minus second vars Binompdf. Yours might have the wizard display, in which case you're still putting the same numbers in the same order. It's the number of trials, 5, the probability of success, 0.5, and the at most value, in this case at most 2. So Binompdf 5, 0.5, 2. Hit enter, gives you the same value. So at a minimum, you have 2 different ways to do it, both giving you the same answer. At most, you have a technique that you can use to check your work and make sure that you're doing it right. All right, so pretty solid stuff. Either way is fine by me. Just pick the method that you're most comfortable with and go with it. All right, number 5, a psych quiz contains 30 multiple choice questions with 4 choices each. You decided not to study because you were too busy preparing for a statistics test. So you need to guess the answer to every question, every single one of them. So we want to know the number of questions, that you expect to get correct. Expect is the key word. All right. You want to get you don't want to get in the habit of thinking these questions are asking for your opinion. You know, how many would you expect? Like half, like 20, I don't know. No. It's mu equals NP. Because mu, or the mean of a probability distribution, is the expected value of that distribution. All right? you have 30 multiple choice questions, each with 4 choices, which means you have a 1 in 4 chance of getting each question right. So I'm going to crank out 30 times 0.25. So I'm not going to expect to get any more than about 7.5 questions right, but then again, you wouldn't expect to get 7.5 questions right if it's multiple choice and you're not getting partial credit. But that's what the math tells us. So 7 to 8 questions. All right. The standard deviation. Sigma is equal to the square root of NPQ. Now Q is 1 minus P, so an alternate way of writing this formula is NP times 1 minus P. All right. We've already established that P is equal to 1/4. Poor quality 4. So here we're doing the square root of 30 times, I'm going to write 0.25 instead of 1/4, and 1 minus 1/4 is 3/4, dollar minus 1/4 is 75 cents, 0.75. So we're looking at about 2.372. That's all that question's asking me to do. Now it says, would 20 questions, correct questions, be considered unusual? Now again, it seems like it's asking for your opinion. It is not. It's asking you to use the usual unusual formula. Mu plus or minus 2 sigma. All right, so I'm going to try to work with the more exact value there, 7.5 plus or minus, I'm going to write 2.372. But what I'm going to do is I'm going to store that value that I just came up with. I'm going to store, hit the STO key. I'm going to store that in as like S for standard deviation, S for sigma. All right, you get your S a little bit differently. You would hit alpha and then something in the neighborhood of 5. No, it's alpha and then the LN key. But you can call it anything you want. You want to call it A, you want to call it B. So hit alpha math to call up A. Doesn't make a difference. All right, so 7.5 minus, oh, you know what, I deked myself here. 2 times. I want to try to, I tried to salvage it, I can't. So plus or minus 2 times. The fact that the number had a 2 in it, I confused myself basically. But 2 times S, that'll give me my low bound. So 2.757. And then second enter to bring up that previous computation. Delete. I'm going to insert, so second delete. I'm going to insert a plus sign. That gives me my high bound. So 2.243. Oh, I'm sorry, 12.243. All right, so these are my usual suspects. All right, so my conclusion here, 20 is way outside of that. So therefore, 20 correct is unusual. Yeah, 20 correct would be unusual. It doesn't fall within that interval. It's not between 2.7, 2.8, and 12.2. All right. Next up is number 6. 12 marbles are placed in a bag. 9 are white, 1 is red, 2 are black. Design a simulation that could be used to determine the probability of selecting the red marble after 100 trials with replacement. All right, so here I'm not looking for you to actually give me the outcome. I'm just looking for, I mean, if you want to give the outcome, you can give the outcome. But my thinking is people could just make up those numbers. So it doesn't benefit me too much. So the red marble. Well, we have 1 marble that's red, and we have 12 marbles overall. So what we can do is I'm going to use 0. Oh, you know what? I'll use 1. Let 1 equal the red marble. We have 9 that are white and 2 that are black. So what I can do is I'll account for the black ones now. 2 and 3 are the black ones. Although it really doesn't matter, because it's really like 1 is red and the other 11 are not red. Right? So that's really all it's going to come down to. But, you know, this is fun too. For the 4th one through the 12th one would be the white. I thought about color coding this one, but I didn't think it would go over very well. I did that once before. Somebody got very upset. So these are the ones that are not red. So we're going to do a random integer. Rand int numbers from 1 through 12 100 times. And so what we would want is the number of ones. Those are the reds over 100. That's all I'm really looking for. I mean, if you want to do the calculator work, you're welcome to. But like I said, that's something that's easily made up, so there's no point in me doing that. All right. So I mean, I'll do it for fun. Math probability, option 5, 1, 12, 100. I just really, the whole point behind this exercise is for you to demonstrate that you know how to set up a simulation, not that you know how to carry one out. All right. So I would sort my information, sort ascending. Oh, I never stored my data. Do that again. Store it into L1. Then sort out my L1 in ascending order. Then I would go into my editor and just keep going till the 1 stop. So the 13th value would be the last one. So I would get 13 out of 100. All right, not necessary to write down, so I don't want to confuse people any more than I already have. So I'm just going to leave this problem at that and not actually write the number, but just so you know, that's how you'd carry it out on the calculator if you so choose. Next one, very, very easy problem. Notation makes it seem like it's more challenging than it really is. So we want to know the probability of selecting heroin given that the category is 18 to 25. So the given is where you're living. Given is where you're living. So only within this category am I looking for individuals who, I can't even remember what the scenario is about. Oh, yeah. Oh, number of thousands. This is horrific. All right. Well, heroin users in that 18 to 25 group. All right. So there's 47 individuals who would be categorized as heroin users. And there's 2,526 individuals overall. And that is all we need. All right, so you're basically restricting the table based off of what comes after the vertical slash in the problem. And whatever comes before it is really what you're looking to find the probability of, just based on that subset of the table. Now, this question says construct a tree diagram or list a sample space. You could very easily be asked to do a tree diagram or a sample space. Not like you're given the choice, but I'm saying that maybe the question on the test will say construct a tree diagram. Or separately, it could be construct a sample space. Maybe one version of it, which would go to half the class, would have one type of problem, the other version would have another type of problem. All right, so yeah, I'm basically telling you that there's going to be multiple versions of the test, and you got to be careful. All right. So anyway, I'll do them both for this problem because it wouldn't hurt to get that review. Construct a tree diagram or list of sample space for a roll of a die followed by 2 tosses of a coin. All right, so let's talk about the roll of a die. I'm going to be a little bit more specific than, I guess, I'm going to write roll of a die because I didn't want to write the word die, just as a standalone thing. All right, so 1, 2, maybe a little bit more space. Those are our outcomes for a single roll of a die, followed by 2 tosses of a coin. All right. Oops. Fix that. Coin, toss, number 1. All right, so for each outcome in the first trial, I would have 2 outcomes in the second trial, heads, tails. So that's 1 toss of a coin. Now I need a second toss of a coin. All right, so coin toss number 2. All right, so might get a little tighter here. Maybe we'll just move this over a smidge. These tend to get messier and messier for larger numbers of trials. So not looking for a work of art, and when I zoom out on this, you'll see what I mean. Just looking for you to get the job done. Okay, so for each outcome in trial number 2, I have 2 more trials, 2 more outcomes associated with trial number 3. All right. Now, that's the tree diagram. Now, I'm not asking you to put probabilities on this. I think that would be unfair. It's already lengthy enough as it is. All right, so this is a tree diagram. You can make a sample space without making a tree diagram first, but oftentimes life just is a whole lot easier if you make a tree diagram first, then the sample space. But really, if you consider it, and I'll just kind of pretend that I don't have access to a tree diagram, easier said than done, I guess. But if I were to think about it, I'm rolling a die and then flipping a coin. So my possibilities are that I would roll a 1, and then maybe I would get a heads. All right. But then if I got a heads on the first roll of or flip of a coin, I could get a heads on the second. Maybe the 1 and heads was followed by a tails. Then 1. So I've already accounted for my 1 heads, tails. But maybe what if it was 1 followed by tails? Then I could get a heads or tails after that. So heads, 1, tails, tails. All right. So then it's just really, I don't know, an exercise in avoiding writer's cramp, I guess, because it's going to be the same array of outcomes for 2, 3, 4, 5, and 6. So you just got to do it. Now, if you have the ability to copy and paste, that makes it even better. I'm going to pretend I don't have that ability. I kind of don't anyway, because with this app, it's not as easy as some other apps. So I'm going to do it like I did it back in the day when I had to write the words, the vocabulary words. I had to write them like 5 times each, whatever it was. You just kind of write it letter by letter down the line. The idea is to replace, like you have a choice between thinking and writing versus just the writing without the thinking. That's going to make life easier. You will see a deterioration in the handwriting as you go, though. And I'm fine with that. Not doing any thinking. No thinking whatsoever. A mental break. I find T's to be easier to make than H's, so I'm going to crank out all my T's. Get my commas in there, and then finish up strong with my H's. And that's a high quality sample space right there. SS for sample space. Alright, so either way it gets the job done. Both of them involve having to do a lot of notation. One of them is going to be easier than the other, I would imagine, based on personal preference. But you could be asked to do one or the other, not necessarily giving you the choice. Alright, moving along to number 9. This is going to be much easier than that last one, because you don't have to do as much writing. 3 geometric figures are selected. That's a typo. Typo bonus for somebody. From a sample below without replacement. What is the probability none of them are triangles or hearts? So the probability, so I'm going to write in notation form, probability not triangle and not a heart. All right, and that's going to happen for the 3 instances. All right, so if neither of them are triangles or hearts, I don't want to get into the logic of it. If anybody's interested, that's an Easter egg. I'll throw in a nice little Easter egg for somebody. It's called De Morgan's laws. All right, so De Morgan's laws justify why the negation of an or becomes the 2 components negated with an and in between. All right. So the first person to send me a message, all you'd have to indicate is in the review video, the Easter egg is De Morgan's laws, and I'll throw you a bonus point just for picking up on my Easter eggs and watching the video. All right. So basically, what I'm doing here is looking for the probability of 3 things without replacement. So 1, 2, 3. All right. None of them are triangles or hearts. So I don't want triangles or hearts at all. So let me get rid of the triangles and let me get rid of the hearts. All right. Part of this becomes an eye test because, people who've gotten this problem wrong, or people in 2019 who got this problem wrong, they got it wrong because they didn't see that last triangle there. All right. So if they're not triangles or hearts, then what we're looking for is the probability of anything but a triangle or heart. So probability of anything else. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 other things out of the 12 that are available. Then if I select one at random and don't replace it, then I only have 8 of the things I want out of the 11 things available. Then if I select another one without replacement, then I only have 7 of the things I want out of the 10 things available. So then it's just straight up multiplication. Multiply tops and the bottoms. Now, it's up to you how you want to represent this. Just be careful on the test. On the test, there's going to be instructions on how your answer needs to be represented. In some cases, it's going to be as simple as, just give me an answer, I don't care. In other cases, it's going to say, give me a fraction. If I ask you for a fractional answer, it does not matter which form you put your fraction in. It could be in simplest form, or it could be in unsimplified form. All right, either way is going to be fine. So if you have it in simplest form, you might have gotten 21 over 55. Full credit for both. All right, if you went to decimal form, the proper decimal equivalent would be 0.382 if you're going to 3 significant digits. All right, that third digit would round. All right, oh, look at that. There's an E and else. Hello. All right, the very last question here. On this test, this would be an omit for some people, but you can't guarantee that it's going to be omit for your test. How many events are in the sample space of 3 rolls of a die? All right, there's 6 outcomes in a single roll. I want 3 rolls. All right, so it's number of outcomes per roll per trial raised to the number of trials. All right, but there's a second level to this. 4 followed by 4 flips of a coin. 2 outcomes for a single flip. 4 flips. I'm going to crank this out in my calculator. 6 raised to the 3rd power times 2 raised to the 4th power. 3, 4, 5, 6. All right, so 3,456 would be the number of trials. I'm sorry, number of outcomes. And there it is.